Hey, fourth grade family. So I had been telling the students that I would record a video on division. I had done that before Christmas, but for some reason it didn't post to YouTube. So just now getting back to that because we're back getting into the swing of school and we're going to be reviewing division in class and on homework. So I wanted to make this video to just show you the strategies that we are using and the strategy that they need to leave fourth grade knowing. So I'm going to actually do the first problem on their homework. It's a two-step problem. So it says students at an elementary school are having a pizza party to celebrate the end of the school year. There are 186 boys and 228 girls at the school. If a pizza can feed 5 students, how many pizzas are needed to be sure every student has enough to eat? So typically, I really try to have them read it twice at least and making sure they are visualizing the problem. So in this problem, they are going to have to add the number of boys and girls first because they have to know how many total students there are in the school. So when we add, we are doing the traditional algorithm. That's different from third grade. But as I tell them, we are sophisticated fourth graders. We are now using the traditional algorithm. So 6 plus 8 is 14. We carry the 10. 1 plus 8 plus 2, that would be 11. So I leave my 1, carry my 10, which you may hear them say, well, that's 11 10. So they leave the 1 10 in the tens place and carry the 100. Then 100 plus another 100 plus 200 is 400. So there is a total of 414 students. Now, I'm going to write that number up here so I don't forget it. And I'm going to erase so I can show you our division strategy. Now, some students will use a number bond or an area model, but we really are working toward using a strategy that's very similar to the traditional algorithm for division. So that's what I'm going to model here. So going back to the problem, the pizza has to feed 5. If a pizza can feed 5 students, how many pizzas do we need? Okay, so we're going to take that 414 students, and we're going to divide it by 5. You may also hear them call this vertical form, okay, because we're actually going to get the answer vertical. So first thing I ask them is we look at 400s, and you will notice that this strategy is very rooted in place value. It builds on what we've already done in class. So I asked them, can I do 5 divided by 400? Well, I could, but it's not going to be very efficient. Okay, it's going to give me a big number. So then I'm going to go look and I'm going to think of 41 tens. Can I divide 41 by 5? Well, I can't do 41, but I can do 40. I can do 40 tens. So 40 tens would be 400. So 5 times what equals 400? So if I know that 5 times 8 is 40, 5 times 80 is 400. So I know I'd ask them here, can I do 5 divided by 400s? If we think of that place value chart, I would have to break up those 4 place value discs and move them to the tens. That's why it sounded the same that I asked them, but if I reword it with the place value, it makes more sense. So far, we know we need 80 pizzas, but we still have some students left over that need pizza. So we have to subtract. So far, we have served 400 students. We have 14 students left that we need to serve pizza to. So can I do 14 divided by 5? Well, the closest multiple of 5 that I can get to is 10. So 5 times 2 is 10. Okay. So So far, we need 82 pizzas. But we had 14 students left and we gave pizza to 10 more. We still have 4 students left. So you may see students write, okay, well, I have 82 pizzas and I have a remainder of 4 students. Well, the question says, how many pizzas are needed to be sure every student has enough to eat? 82 is not going to be enough. So we're going to have to order 83 pizzas. The answer to the actual division problem is 82 remainder 4, but because the context of the problem asks us to make sure all students eat pizza, the answer is 83. Okay, so you'll notice this vertical form looks very similar to traditional algorithm. It's just that we are putting the emphasis on place value still. That we're putting that 0 in with the number, with that value. Okay, so I'm going to go ahead and post this video. I will probably be making another division video with a higher number because we do go into the thousands. So if you have any more questions, just let me know. Thanks, guys.